I'm very, very pleased to introduce our second keynote speaker of the day. It's Major General William Cooley, who, as all of you know in the meantime, is the commander of the Air Force Research Laboratory at Wright-Patterson Air Force Base in Dayton, Ohio. To put General Cooley's role into perspective, he is effectively a very senior technology leader and manager. He oversees a research staff of 10,000 people and a budget of between $5 and $6 billion annually. And he commands research centers and sites across the globe, actually. And in his case, as with AFRL institutionally, there's this long history of getting behind emerging technologies and looking very deep into the future at how those technologies can be implemented to execute the mission of the U.S. Air Force. And so the General is going to give us a very interesting high-level perspective on that, on how he sees this. One aside, as a former Air Force officer, I do note the kind of cruel irony that the real brain trust of the Air Force research activity is in what is not, unfortunately, the garden spot of the country, Dayton, Ohio. Like the Air Force actually has installations in Los Angeles and across Florida, Colorado Springs, but they're sort of telling all of the brain power around the Air Force, if you want to do this really interesting work, you've got to come to Dayton, Ohio. So they're really proving that they really want to do that job. But anyway, we're hoping that AFRL does, in the course of time, establish some kind of a more formalized toehold someplace in Silicon Valley. And we've told the General before that he is extremely welcome here and all of his colleagues. So without further ado, I'm going to give you General Cooley. Thanks a lot. Thank you very much.
Thanks. Thank you very much, Matt. I appreciate the introduction. I don't know if I should comment about the weather in Dayton, Ohio. We have a lot of our folks are from Rome, New York as well, so a little bit different weather patterns than exist here in on the West Coast. But I would take us back a little bit because it's a good context-setting thought piece, if you will. The reason we're in Dayton, Ohio was the Wright Laboratories. In fact, the predecessor organizations for the Air Force Research Laboratory started in 1917 because the Wright brothers had invented aviation, and that was sort of a hub of that innovation coming out of that. But I think it's important to maybe reflect back on even before the Air Force began. That was the Army Signal Corps, and we really started understanding what aviation could do for the military. I think that sort of set the foundation for why I'm here today, because this is about technology. And so through the crucible of World War I, the airplane represented a way in which to go over through the third dimension, directly at the heart of the enemy versus going through the trenches that had been built up. And so the technological advantage and promise that held is really what the Air Force was born out of. Fast forward to World War II time period, and Hap Arnold, who was the Chief of Staff of the Air Force, first Chief of Staff of the Air Force, recognized the important coupling between technology and the Air Force and the national security enterprise. We certainly saw that in World War II with the advent of radar and various communication devices, the Enigma machine. I'll talk maybe a little bit more about that because that's what got us into this cryptography, or some of those advantages for information dominance. But Hap Arnold said something that is sort of the theme of the Air Force Research Laboratory, and I would share that with you because I liked it so much that I had it put on my coin. And that is, here's a quote from Hap Arnold. He said, "The first essential of air power is preeminence in research." The first essential of air power is preeminence in research. And so that's why we're here today. That's why Air Force Research Laboratory is here today. This is an emerging field. This is an exciting time for those who have been working in this quantum information system arena. But the reason I'm here today is that we seek to understand and partner with and leverage this emerging technology. So go to the next slide, please. So here's really the context, and let me just spend a minute talking about two of these. I'm going to talk mostly about the potential applications, which is that second bullet. But the first bullet is really a recognition that we're at the beginning stages of what quantum capabilities, not just quantum computing. I recognize that most of the folks here are largely interested in quantum computing and the promise that holds. And I'm very grateful to Professor Preskill, who gave my brief to a large degree, because he talked about many of those other applications that quantum capabilities may enable. And those are some of the things that, from an Air Force standpoint, we're very interested in potentially exploiting and understanding and engineering. But let me just hit on, there's still a lot of science to do in this area, even though quantum mechanics was, sort of invented and first envisioned at the turn of the last century. The engineering and the components and the details of actually making these things happen is a real challenge. This is one of the areas I'll talk a little bit about, some of the things that we're doing within the Air Force Research Laboratory. But we seek to accelerate that to as much as possible to good effect for the United States Air Force. I'm going to spend most of my time talking about some of the applications. And as I said, Professor Preskill hit on that timing, the sensing opportunities that we may be able to exploit, the communication, and the networking. But the last key contextual element is the partnerships. That this is an ecosystem. The players in this quantum technological advancement. You saw the sponsors, all of the different players. We exist in an ecosystem to try and learn from one another to advance the state of play, so that we can potentially start to bring some of those early applications both to the business world, as is the name of the conference, the Quantum for Business, and as well as for the national security activities. So that I don't forget, let me hit on that international efforts. One of the things we are very cognizant of is that there's a lot of international efforts. We recently are partnering with our closest allies to specifically get after some of the activities in position, navigation, and timing. As Professor Preskill mentioned, this is an opportunity to leverage the very precise and high fidelity inertial navigational type systems for a GPS denied environment. And the UK, we're working with our British counterparts, with the Canada, Australia, and New Zealand in a Five Eye effort to try and bring the best scientists in this area to accelerate some of those technologies. Okay, next slide. Okay, I could probably do the entire briefing on this one slide, the sort of operational view of where we see potential opportunities for quantum systems. And we've tried to sort of color code this and make it easy. So the colors, or the Rosetta Stone is in the left corner there. So there's really these four aspects, if you will: quantum timing, sensing, communication networks, and computing. And we see potential applications for our military, future military capabilities in each one of these. Let me start with what I think we believe is probably the nearest term, and that is timing, in quantum timing. Let's see, 2 jobs ago, I was the director of the Global Positioning System. Yes, your Air Force brings you GPS. We run a global utility for all the many applications, both military and civilian. And so we launch satellites, and I would daily get updates about the accuracy of GPS. And it's pretty remarkable. And so we would track very closely all of the different contributors to the error associated with GPS. And it varied day to day. Ionospheric errors, of course, are one thing. Clock drift, our ability to update the various system. Well, let me talk about clock drift, because that is one of those contributing errors. Today, the atomic clocks we use on GPS are somewhere on the order of, have a drift on the order of a nanosecond a day, let's say, on that order. That requires us to ensure we're constantly updating that, because that 1 nanosecond error actually contributes to the overall accuracy in pretty significant way. So there's opportunities to go to use cold atom clocks and drive that error down with some of the technological components. And of course that ripples through the entire system. The entire global market or users would benefit from that. But there's also applications not just on the satellite, but for terrestrial applications where we absolutely got to have precise timing to bring that to bear and have stability over a long term. The next piece is the quantum sensing, and again, Professor Preskill hit on this. Opportunities for position, navigation, and timing, that inertial measurement, very accurate inertial measurement unit to measure accelerations and rotation, to calculate exactly where you're at, but also to potentially measure the gravitational field. There's efforts to map out the gravitational field and use that as a tool to help understand where you are on the planet. The gravitational field and the magnetic field. So both of those are potential sensor applications. And then another application is to measure, tunnels, bunkers, and those kinds of things. The accuracy potentially enables us to identify if there are gaps in space and what the mass is based on the gravitational field. So there's real opportunities in sensing. So we see those as two, well, not just militarily unique, but clearly some things that we would like to leverage for advanced technology. The next two are the communication, and I can't probably do any better than what Professor Preskill did with respect to the assurity of communication and ensuring that your encryption is not broken. And there's different ways to get at that, but clearly the technologies and the capability to reliably produce entangled photons and use it as a communication system, and then to take the next step as a networked system such that you have these nodes and repeaters. We're not there yet, but we're very interested in advancing the technology. And then quantum computing, finally. And all of you all are a lot smarter on quantum computing than I ever will be. And this is an area where we clearly think there's applications for the military, for the Air Force and the broader national security. But frankly, we hope to leverage what is going on in the commercial space. Okay, next slide. Okay, next slide. Let me talk first about some of the things that we're doing within the Air Force Research Laboratory. As Matt said, we have a very large footprint across the United States, a lot of scientists who are keeping track of the investments across academia and industry. But we also have some things that we're specifically working on because they're hard and sometimes militarily unique problems. Here's a short list. So across the laboratory, since Matt kind of mentioned it, yeah, the investment is somewhere, the total investment somewhere north of about $5 billion. A lot of that is external money that we get. But I think maybe most importantly, it's just to get a sense of the locations. The center of gravity is at Wright-Patterson Air Force Base. I will just say that the cost of living at Wright-Patterson Air Force Base is a little different than it is here on the West Coast. And it's a wonderful place to raise a family, and we're doing some great science. So, but that said, we certainly want to engage with the pockets around the country. We mentioned the site up at Rome, New York. Colonel Tim Lawrence is leading the group up there, and that's probably the center of gravity for what we are doing in quantum. I would just mention that some of the research that's going on up there is exactly some of the central challenges that Professor Preskel talked about with respect to those repeaters and being able to build up a comm network to the extent that we can have atoms that will hold information and be able to interact. That's a serious challenge, and that's one of the central pieces that Dr. Kathy Ann Soderberg and Paul Alsing are working towards. The Air Force Office of Scientific Research, many of you probably are familiar with AFOSR. We invest in basic research and fund academic researchers in this area and many others. But they're an important player. Down at Eglin Air Force Base is our weapons portfolio. And then out at Kirtland Air Force Base, both the the directed energy, lasers, high power microwaves, as well as space vehicles. And so there's a significant effort going on out there with respect to what could we do to advance the state of play for quantum communications via satellite, as well as the lasers, critical for maintaining, cold temperatures and that enable all of this. So there's a very brief list of some of the activities that are going on across the enterprise. But this is still in the early stages, but we recognize how important it's going to be going forward, and that's why we are making the kind of investment that we are. Okay, next slide. Oh, I would also mention that you saw we have a footprint around the globe, as Matt mentioned, in Tokyo, in London, and Santiago, Chile, where we really try and engage with our international partners. Okay, these next few charts are what we like to call our swoop charts, and it's just really shared to give you a sense of where we are today and where we think we are going, in the long term with some of these capabilities. I kind of talked about some of these, so I'll move it along. But today, with respect to the opportunity for precision timing, we see an opportunity to significantly increase the GPS capability, or maybe I should say decrease the error associated with clock drift for the GPS, but also, longer term, making clocks smaller and more versatile and to have a robust system that's not reliant on GPS. From a military standpoint, we're concerned about the vulnerabilities of GPS. As everybody knows who knows anything about GPS, it's a very low signal in the background, and so it certainly is something that can be jammed under certain circumstances. We're working on that on a number of fronts, but clearly having a capability that is not reliant on that signal is central to our thinking. Okay, next slide. With respect to sensors, we talked about some of this. This is specifically for the position, navigation, and timing. What's today's IMUs, or inertial measurement units, are pretty accurate, but they're heavy and large, and they don't have the level of accuracy that we believe is possible with quantum sensors. And so that's where we'd like to go, is to make much smaller quantum sensors with high fidelity position, navigation, and timing in a GPS-denied environment, without GPS. In fact, this is the area, as I mentioned, we're working with our Five Eye partners, or allies, to develop, to actually build some prototypes and see what is in the realm of the possible if we started putting together sensors, and what kind of accuracy do we actually think we can deliver. Okay, next slide. In terms of quantum networks, There has been work, I think, in the last couple of years. We've seen in the press that China has put a significant effort in terms of having a quantum key distribution from a satellite. That's certainly something we're looking at, but we see the longer vision in terms of the types of capabilities we would need to build out a communication architecture and the technologies associated with that. Those are the types of technologies that we're currently investing in and seeking to leverage with respect to those who are in that same area. As was just mentioned by the previous talk, there's a lot of heavy lifting. There's a lot of technology that's got to go into making the network possible. But we certainly see the advantage, and that's why we're investing in this and paying close attention. And you can see that sort of the yellow bang box, to get to that tamper-proof point-to-point communication is really essential. Something that we want, and we would like to. We're very concerned if potential adversaries get there first, and so we're leaning into this and running fast. Next slide. With respect to the networks on the ground base, as was previously stated, again, I'm grateful to Professor Preskill for his talk. Going to a network system on the ground over fibers is even harder than the satellite piece. We think we need to get there, and we're making some investments to make that, but the number of nodes and the number of repeaters and the challenge of translating that is non-trivial. And so we've got some specific investments. In fact, this is one of those, as I mentioned, the areas that our folks up at Rome are actively engaged in to go and prove this out, build up some nodes and start to learn from that experience.
Yeah.
Okay, next slide.
I just want to know.
Okay, and then finally, the quantum computing. We think that there's, we genuinely believe that there are problems that we'll be able to solve much faster and more accurately than currently exist. And that's by leveraging the investments in quantum computing. So we have a team who is engaged in writing algorithms, understanding what the limitations are with respect to the interaction with the current state of play or the current quantum computers. But this is an area where we don't want to have to learn, be the last to sort of learn and figure it out. So we're directly engaged in this. You can see we've got a number of, today what we're doing, we're engaged with the quantum computers that have been made available to do some programming to understand with the rest of the community. But long term, we think that there's a real advantage. And I would just emphasize that this is an area where partnerships is probably the active word. We are seeking to partner with those who are advancing the quantum computers in particular and the algorithms to understand what the opportunity space looks like. Okay, next slide. Okay, in summary, whether this is game-changing or not is unknown. We're still at the very early stages of this. I've tried to figure out what the best example is or comparison. But this, we may be in the 1920s for aviation time period where there's opportunity space, but we haven't really figured out exactly how we're going to employ some of these things and exactly how useful it's going to be, whether or not we can achieve some of the goals and the visions that have been articulated. Right now, the challenge of solving the tough engineering problems, shrinking things down in terms of size, weight, and power, and stability are a real bugaboo from what we have seen. And that's why it's going to take a community-wide effort. It's going to take an ecosystem to advance the state of play, and that's why we're here to work within this community and seek to understand what the big problems are and how the U.S. government and how the Air Force in particular can help in that. I've talked about the way we're thinking about this, the timing and sensing are probably the earliest opportunities. Longer term, we think that communications, networking, and computing algorithms show real promise. And then, as I mentioned, that the partnerships, the supply chain, the building up the components that are required for any of these, and then the workforce development. I think that I know in our case, we've had some very smart quantum researchers hired away by some of you smart industry folks. That's good. They're part of the ecosystem. But it is a workforce development, and it is the same ecosystem. And so we're seeking to make sure that we're developing the workforce that's going to be smart enough to advance the state of play. So that's my last slide. Kind of short and sweet. I want to make up a little bit of time, but I also love questions. What I normally tell my staff when I do commanders calls is, I'm not leaving until I have at least 3 questions. So you're not slowing us down. So with that, let me pause and see if there are any questions from the audience. I see a question right down here, sir.
Can you hear me? Okay. Hi, my name's Austin. I'm actually a part-time lecturer at Ohio State. And you were talking about workforce development. So as I'm growing my own students, what are you looking for in this future workforce for quantum computing?
What am I looking for in terms of this future workforce? That's odd. Well, one of my favorite quotes from Yogi Berra is, predictions are hard, especially about the future. I would say that one of the things, and the reason I use that quote is, I'm thinking about, it's hard to know precisely what skill set and insights that future workforce is going to have. But what I would tell you is that from our experience, the importance of multidisciplined understandings and insights cannot be understated. And so, although we need pure theoretical folks, we also need people who have an insight in terms of how tough, why the engineering challenges are particularly hard. And so getting that breadth of experience and insight and sort of in that cross-discipline kind of thing, because many of these problems are not just I'll say a pure physics problem, in terms of solving a Hamiltonian. It's how do you bring all of the various disciplines together? And so if I was going to speak to that, I think that's what I would encourage academics to appreciate as you are producing that workforce, the next generation workforce. Absolutely essential from what we've seen. Good question, thanks. Other questions? Am I not going to reach my 3 quota? There's a question back here. Yes, sir. Oh, it's Alan. Oh, no, this is okay, wait. I don't know if I want a question from him. This is going to be tough, so my lifelines are in place. Okay, go ahead, Alan.
When you talk about sensing and timing, what do you think would be the commercial applications of sensing and timing, and how can the two kind of work together?
Great question. Well, I can think of a couple that are sort of directly tied to GPS. And like I said, in a prior assignment, I got to lead the GPS enterprise from Los Angeles, and get to know Brad Parkinson, who's sort of the father of GPS. And they could never have possibly imagined how GPS is used today when they started it back in the early 70s. And when we committed to starting to launch satellites and everything. The precision agriculture and all those kinds of things that have fallen out was in nobody's mind at the time. So I guess I bring that up because I would answer your question sort of in a similar light. The creativity and the innovation of how does one apply potential technologies to new problem sets or create new markets that were never heretofore thought of. I think is the opportunity space. And so as I think about timing and sensing, the dependence right now on GPS accuracy and what is capable because of the timing accuracy and the linkage, for example, to the financial markets, right? I think that there's probably some folks who would be very interested in having some backup, very high reliable clocks on the timing side. On the sensing side, who knows? The sky is the limit in terms of if we can start to drive the fidelity and cost of quantum-based sensors, much further. My guess is there's a lot of different market spaces that you and I have not thought of. That there are probably people sitting here in this room who are thinking about that in this competitive market space, and that's great. We'd love to see that because that's what's going to help us drive technology. I don't know if I answered your question, Alan. Good question. There's a question right down here. He's got the mic. There you go.
I want to make sure you get to your third question.
Thank you.
So you're talking about the 2035 timeframe as when things really start to break open. But what sorts of changes do you see in the, say, 2025, 10 years before that?
That's a great question. Back to my Yogi Berra quote, it's hard to know when some of those things are going to accelerate.
But you already predicted 2035, so this one should be easier.
I'm giving myself some margin, okay? So if we pull things to the left, great, right? I guess I would say that in terms of the 2025 timeframe, I think we see, near-term applications both in the timing and the sensing opportunities. Now, what the precise timescale is, I don't know. We are working across the DoD, the national level enterprise, and with our allies to see how fast can we potentially accelerate some of these things. So as I think about the phasing, if you will, of the types of capabilities we would see, I think that's the order in which I would project we would start to see them from a military employment, from incorporating them into to our systems. But I could be wrong, right? This is one of those things that invention space and the opportunities and the commercial market that come to the extent that the commercial market can accelerate some of these capabilities to the left. Trust me, we are going to be flight following that and leverage that to the maximum extent possible. So. Yeah, I'm glad I used that Yogi Berra quote. Those are time frames in terms of the time epics. We know where we are in the maturation of some of these things. These are really hard problems. That's why we're all here today. But we're anxiously, investing in and seeking to move all of that to the left, those capabilities to the left as much as possible. So, thanks for your question. Okay. With that. Other questions? Oh, there's one more back here.
So, General, can you give us some guidance about collaborations that cross national boundaries?
Give you guidance about collaborations that cross national boundaries?
Yes. You've touched on several sensitive areas, and so I wondered what your attitude or ways of encouraging or appropriately modulating those collaborations.
That's a great question. Which I have given a lot of thought to, and I would say that the current way in which technologies are advanced, the current sort of the status quo of the ecosystem, in which conferences like this are open to the public and people publish papers and we share ideas, that is an extremely healthy way in which technologies are advanced and we learn and discover. One of the things that I'm spending some time thinking about is what are there areas in which in which the government needs to potentially play a more substantive role in investing and potentially protecting. In this area, we're at a very, I'll say, immature state, and so we're mostly just kind of watching the development. This is science, right? There's nobody that has a monopoly to sort of pull all these things in. So we're very closely watching how science is going to evolve. So I guess I would leave it at that point. I think the ways in which the ecosystem works to advance technology and science are healthy, have been productive, have been proven, and so that's exactly what we're going to continue to do until there's reason to do otherwise. And I believe that Dr. Jake Taylor from the OSTP is going to be talking about some of this later. So I would recommend that maybe you save that question for him as well, because he's thinking about this in that whole of government context as well. It's a challenge, but right now I see us as a very early stage research, and we certainly want to leverage the health of the ecosystem and the ways in which that works as much as possible. It's a good question. It's a tough question too. Thanks. Okay, with that, let me turn it back over to Matt and say thank you very much for having us be part of this event. This is the second Quantum to Business conference. My hope is that we continue to stay engaged and leverage this community and this ecosystem so that we can all help advance this technology together. So,
All right, General, we want you back next year. Thanks very much. And next year when you come, we hope you bring along your brethren and sisters from the Army and the Navy, from the research components.
absolutely. Yeah, absolutely. In fact, I will tell you, I collaborate very closely with my sister services. Admiral Dave Hahn is the O&R director. I think he was supposed to be here. He had to reschedule. And then from the Army, General Cedric Wins is sort of leading that enterprise. They were both engaged, but they are certainly part of this broader conversation.
Good.
So,
Well, we're looking forward to that. Thanks, General.
for the
Thanks very much.
Thanks.
Okay.